All right, here we are in chapter 4. We're talking about samples and surveys. So we're going to kind of take a sharp turn here. This chapter is very vocabulary heavy. So we are going to start by looking at identifying the population and sample, identifying voluntary response samples and convenience samples. So again, those are different vocabulary. We have to be able to identify and explain how these sampling methods can lead to bias. Describe how to obtain a random sample using slips of paper technology or a random table of digits. Distinguish a simple random sample from a stratified random sample or cluster sample. Again, those are some vocabulary we need to learn. Giving the advantages and disadvantages of each. Undercoverage, non-response, question wording, and other aspects can lead to bias. So let's start by talking about a few vocabulary terms. The first is population. The population in a statistical study is the entire group of individuals we want information about. A census is if we're taking information from every individual in the population. A sample is a subset of people in the population that we actually collect data from, which is more realistic because generally our population is large and it would take a tremendous amount of effort and time to take a census. So we take a sample, collect data from a representative sample. What we want to do is then make an inference about the population. You might remember this little figure from chapter 1, and it comes back again because this is a really important concept in statistics, is that we're going to look at a representative sample, but we essentially want to make an inference about the population. So we have a little bit of ways to go before we can do that. We have to understand some background first. So the idea of a sample survey, we want to, again, draw conclusions about a whole population based on a sample. We want to choose a sample from a large, varied population, but that's not always very easy. So what we first want to do is define our population. Step 2 is say what we want to measure. A sample survey is a study that uses an organized plan to choose a sample that represents some specific population. So what we're going to do in step 3 is decide how we are going to choose a sample from the population. There are a lot of ways to do this. So let's talk about a few of those ways. Sampling badly happens a lot. After we know about a lot of these terms, about a lot of these procedures, methodologies, we can then look at reality and say, are these samples that we're seeing in the news, that we're seeing in studies, are these samples taken correctly, or were they done poorly? Were they sampled badly? So how can we choose a sample that we can trust to represent the population? Choosing individuals from the population who are easy to reach, this is called a convenience sample. Obviously, this is going to be the easiest thing to do. If I want to know people's opinions about their movie preference, I could stand outside of a movie theater and get a pretty good sample, but they're going to be unrepresentative. And why is that? Because this is going to show some sort of bias. It might underestimate or overestimate the value you want to know. So in the example I was just referencing, where you stand outside of a theater, they might all be coming out from the same movie if you're standing outside, so you might hear everyone's favorite movie is Legally Blonde, but that's obviously not the case. That would be an overestimate because that's, might be where they came from. So convenience samples are almost guaranteed to show bias, and so are voluntary response samples. In which people decide whether they want to join the sample in response to an open invitation. So if you're sent a link and it says, please answer these questions, I think that it's not the average person that answers those questions. It's generally people, like it says down here, people with strong opinions are the ones that are going to respond to that. They're going to say, yes, I loved my product, or no, this was terrible. It's very rarely that you're going to get someone to answer and say, this was okay. So voluntary response samples are also very biased. All right, so let's look at this example and identify the sampling method used, explaining how the sampling method could lead to bias. A farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Because the inspector is just looking at the top of oranges, that would be the convenience sample. It's convenient to look at the top ones, but it might not be representative of the entire crate. So in this case, the inspector could overestimate quality if the best are on top. All right, number 2, the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call a telephone number to respond yes, and another to say no. There was a charge for calling either number. More than 186,000 people responded, with 67% of people saying no. Because you were invited to call, that would be the voluntary response. And it seems like because we have such a high proportion of people who said no, those are only the strong opinions, right? So those voluntary response is if people really care in one direction. So strong opinions call. The no proportion seems to be greater than reality. We'll put the real no proportion. Okay. So those were how to sample poorly, but how can we do a good job with sampling? And what we want, ideally every time we would have a simple random sample. Oops, sorry. This should be random sampling involves using a chance process to determine which members of a population are included in the sample. So a simple random sample, which is the one that we want the majority of the time, is chosen in such a way that every group of the same size has an equal chance of being selected. So we're going to use some sort of random process to help us select these members. We can use a table of random digits if we don't have technology. So let's look at how we can choose a simple random sample. We need to label every individual. Give each individual in the population a distinct numerical label from 1 to n, where capital N is the last person. We randomize using a random number generator to obtain n integers. So that's our sample size is lowercase n, capital N is our population size. And we can do that with a table as described below here. So again, we want to label everyone, giving as few digits as possible. So if we have 50 people in our population, then we want 2 digits per person. You always want to look at how many there are total, and then each person should have that many digits in their label. And randomize on the table we are going to read consecutive digits, groups of digits of appropriate length from left to right across a line in Table D. So as I was mentioning before, if we're going by 2 digits, then we're looking at groups of 2 as we go across. Ignore any group that wasn't used as a label or that duplicates a label that's already been chosen. Stop when you have chosen your sample size. So let's look at a row. This is line 130 in Table D. Table D can be found in the back of our textbook. And we have all of these different hotels in Hawaii, it looks like. And what we want to do is we gave every single hotel a number label from 1 to 28 because there are 28 total options, and we want to choose a simple random sample of 4. So what we're looking at is line 130 in Table D. You can start on any line if it doesn't tell you to start at a specific line. And we want to look at this in groups of 2. So 69, 05, 16, and so on. You're going to look at groups of 2 like that. So we want to choose groups that are on our list. So 69 is too large. 5 is not too large. We can choose 5. 16 is also available. 48 is too big. 17 we can choose. 87 is too big. 17 again, I'm not going to choose the same number twice, so we have to cross that out. 40 is too big. 95, there's 17 again. Cross that out. 84, 53, 40, 64, 89, 87, 20. So they did break it up into the 2 digits for us, but so we looked at 5 rather, 16, 17, and 20 as our 4. Includes Beach Castle. 16 is Radisson. 17 is Ramada. 20 is Sea Club. Okay. So let's look at different types of random sampling. First we have what's called stratified. So the basic idea of sampling is straightforward. We take a simple random sample from the population and use your sample results to gain information about the population. But sometimes there are statistical advantages to using more complex sampling methods. To get a to get a stratified random sample, first what we do is take our population and divide it into groups of similar individuals, and those groups are called strata. Then what we want to do from there is choose simple random samples inside each stratum so that our simple random sample is made of smaller groups, but all those smaller groups have something in common, and that ensures our simple random sample is diverse. Although a stratified random sample can sometimes give more precise information about a population than a simple random sample, again because you're going to make sure that your sample is diverse, both sampling methods are hard to use when the populations are large and spread out over a wide area. In that situation, we'd prefer a method that selects groups of individuals that are near one another. What we call that is a cluster sample, where we start by classifying the population into groups that are located near one another, and those groups are called clusters. all individuals in the chosen clusters are included in the sample. So that can be, city blocks, it could be zip codes, it could be, as long as you are geographically cities, depends on how large our population is, but clusters are individuals that are close to one another. So let's look at a couple examples here to be able to properly identify the difference between that stratified and cluster, because they are pretty similar, so understanding that difference is important. The manager of a sports arena wants to learn more about the financial status of the people who are attending an NBA basketball game. He would like to give a survey to the representative sample of more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Tickets near the front are over $100 each, while seats at the top are about $25 each. The arena is divided into 30 numbered sections from 101 to 130. Each section has rows of seats from A to double Z. Explain why it might be difficult to give the survey to get a simple random sample of 200 fans. Well, if we have 20,000 people at this game, to get a simple random, we're going to number everyone from 1 to 20,000, but then we have to go find each person. So the difficulty is identifying the 200 seats. That might not be too bad because you can use a number generator, but then we have to go to all the seats all over the place, which would be time consuming to find all 200 of them in random locations all over the stadium. To make a stratified random sample, should we use the lettered rows or numbered sections? Explain. So let's talk about, again, what the difference is between 2 is talking about stratified, 3 is talking about clusters. What's the difference between stratified and clustering? So stratified, we first identify similarities within groups, and then we choose simple random samples between each of the groups. Whereas with clustering, you pick people who are close to one another, and they might be diverse within themselves. So if I'm looking at the 2 different ways I can choose lettered rows or numbered sections, if we want to make sure that each of our groups here, our strata, all have something in common, then we'd probably want to make sure that they paid the same price. That would be their similarity. So the strata, people are all similar within. In our case here, that would be ticket cost. So we want to use the lettered rows. So then which way would be better to take the cluster of fans? Obviously, we know it's going to end up being the other answer here, which is numbered sections. But why is that? Each of the numbered sections have all of the rows inside of them, but they're close together. So for our clusters, we have variability within each group, meaning that all of the different ticket prices are within. So that's going to be the all different seat costs within each group. So we would choose numbered sections as our clusters. So those are extremely similar, the strata and the cluster concept, but we have to remember that strata, everyone inside each one should be similar, and clusters inside each one, although close together, geographically, should be varied within each group. The purpose of a sample is for us to give us information about a larger population. So what we want to do is draw conclusions about the population, That's called inference. That's the big thing that we're working towards here. Why should we rely on random sampling? To avoid bias in selecting samples from the list of available individuals. The laws of probability allow trustworthy inference about a population. So results from random sampling comes with a margin of error, because we're not going to get exactly a perfect sample representative of the population. It's never going to work that way, so there's always going to be some sort of margin of error. But if we have larger random samples, that's going to give us better information about the population than smaller samples. But what could go wrong? What can happen? So even good sampling techniques, if we have good sampling techniques, that includes the art of reducing all sorts of error, but these can still sometimes happen. So what we can have here is what's called undercoverage. That occurs when some of the members of the population cannot be chosen in a sample for some reason. Non-response is when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of incorrect responses in a survey leads to what's called response bias. And then we also have the wording of the questions. That's the most important influence on the answers given in a sample survey. If you word your question poorly, people are going to answer it poorly. So let's talk about each one of those in a context here. Name the type of bias that could result. The sample is chosen at random from a telephone directory. So which one of those, if we go back to this slide here, which one of these things, is this undercoverage, non-response, response bias, or wording of question, that would be affecting choosing random telephone numbers from a directory? It's possible that someone's unlisted, not in the telephone directory, so they would be incapable of being chosen. That is undercoverage. Some people cannot be contacted in 5 phone calls. That would be that non-response where some people just don't answer or refuse to participate. Interviewers choose people walking by on the sidewalk. Not everyone's walking by on the sidewalk, so it sounds like this would be undercoverage because not everyone is available. It's just those people walking by. This is what we called before a convenience sample is being chosen. All right, let's look at number 2. A survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here was the actual question. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for 21% of trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? Explain how the wording of question could result in bias. Be sure to specify the direction of the bias. So really what this is doing is it makes it sound like diapers are not a problem by saying 2% versus the 21%. It seems like because of the wording, we would expect fewer people respond yes. Respond. To banning diapers. With this wording. So, and that means we would expect if this question was fairly worded, we would expect more people to say, yeah, we should probably ban disposable diapers. Okay, so we did everything we sought out to do in our section here. Homework is at the bottom. See you next time.